Okay guys, so today we're going to keep focusing in on those equations that we're going to use adding or subtracting to solve. But this time we're going to get into some word problems. So we're going to go ahead and do some old stuff. We're going to talk about how do we write word problems, and then we're going to launch into 3 practice ones. So first off, what I want to do is talk about words that tell me to add. So again, this list is not exhaustive. We have plus, some, more than, increased. Notice I put that star there in front of more than. And then we have added to. Oops, I just wrote the 2. Okay, let's try this again. Added to. Alright, and then we want to talk about words that mean to subtract. So here's another starred one. Less than, minus, decreased, and subtracted from, and another star. Okay, so what are those star guys all about? Well, remember from chapter 6, those are the ones that change order. So it's an operation word, and the items that came in front of the operation word are going to get written behind the operation, and the words that came after the operation words is going to get written in front. So these are the change order ones. So we've got more than. So I'm going to add, and I'm going to switch the order of what comes around those. Added to, obviously adding. So it looks the same way. We're going to switch the order around addition. We've got less than. And that's going to switch the order around the subtraction sign. And then we've got subtracted from. And that's also going to change the order around the subtraction sign. Looks like a little happy face. Now, because we're dealing with equations, we have some new words. And they are words that tell me to write the equal sign. So I know this is going to sound pretty, yeah, of course, I knew that. Equal or equals. Total. Sometimes total means to add, but oftentimes it means put it all together, which is another one. And is and all to be verbs. So is, are, were, was, will be. Those are the to be verbs. So it's action words that mean our equals. So let's review how do we work with word problems. So I'm going to give you a couple steps I like to follow when I'm solving word problems. And the first one is one that a lot of you are going to go, really? Seriously? You had to write that? And the answer is yes, seriously. Okay. Somehow we ended. I'm not sure where we are, but I'm going to just reiterate. We wrote down words that tell us to add, words that tell us to subtract, words that tell us to change order, and words that tell us to write the equal sign. And I was about ready to launch into word problems and the steps that we follow to solve word problems. I don't know where that stop happened. I apologize. If you need a pause and write this all down, go ahead and do that, and we'll continue on from here. So first thing is you got to read the problem at least twice. Why? First time you're reading to get an idea of what's going on. Second time you start picking apart the information. So next we're going to have some unknown, and in word problems it's usually the question they ask us to answer, right? So it's pretty easy to figure out. So we're going to select a variable, and then we're going to define it in detail. That means we're going to take the words that I couldn't translate to an operation, equal sign, or numbers, and that's going to be my definition. So if we're talking about Bob's age, you just don't say Bob. Okay? If we're talking about Susie's age now, we don't say age. Okay? We want to be as specific as possible. Then we're going to translate. And remember what translate is. It's pretty straightforward. It's kind of word for word or phrase by phrase. And sometimes we have words that change the order. So that's the only thing we have to watch out for. And some of you really struggled on the quiz with that for Chapter 6. But by the time you got into Chapter 6 tests, you guys were getting better at it. So that's all we can ask for is improvement along the way. Okay? And then we're going to solve using inverse operations. To get the variable alone, we're going to have to undo what math was happening in the problem. So we're going to solve using inverse operations. And let me go back. I'm going to talk about something in step 3. For some reason, you guys are stuck in this kind of elementary idea that what do I need to do to solve this problem is what you've been taught. But how we approach it at middle school and beyond is what does the problem say? So we just translate what it says and then we undo the math. So I got to be honest with you guys, in all my years of teaching and being a student, I think I've seen maybe twice in my entire life a word problem that translated with the variable all by itself, and on the other side of the equal sign, it was a number, an operation, a number. Okay, that just doesn't happen. So there should be math needs to happen with the variable. And what I mean by that, I should not just see x equals something. It should be like x plus 3 equals 17. Okay? Don't give me x equals 17 minus 3. I'm not going to give you full credit for that because that's probably not even close to what the word problem said. And now here comes the trick. This is the last piece. We don't write word problem answers the way that we would solve an equation problem. In an equation, they just give us the problem, and we just undo it until we get the variable alone on the left and constant on the right, and the answer is x equals 5. Okay, on this one, we're going to write a sentence, and you guys have been asked to do that, so you're getting pretty good about that. So write the answer in a sentence, but here comes the key part. In a sentence, but guess what's not in that sentence? That variable. So the sentence includes labels, but, and I'm going to yell at you, excludes variables. And here's the reason. Our classes are anywhere between, we got class of 10 all the way up to class of 31. In each of those classes, every person could pick a different variable, even though the problem's the same and we're solving for the same thing. So how on earth can we have people pick different variables? How can, one person have x equals 32, another person says y equals 32, somebody else says m equals 32, another person says k equals 32. How do we get all these different variables? Remember, the variable is not really part of the problem. We just use it so that we can actually write an equation. Okay? All right. Let's get started on our word problem practice. Now, when I go to the next page, and we'll get at least one, if maybe not two, I'm actually not on a new page. I'm just at the bottom of the first page. In fact, I might just do one word problem and then move over to the official second page. All right. Let's get over there. So we're going to do the problem 1 for lesson 7-2-7-3. Suppose Ruben had 147.5 minutes of the 245.5 minutes that were downloaded by Tarek and him. How many minutes did Tarek download? Okay, so let's think about this. I'm going to start with the question because that's going to tell me what my unknown is. So it says, how many minutes did Tarek download? So I'm going to take T and say that's the number of minutes Tarek downloaded. So I just took the words that were right there in the question and wrote it more like a statement, not a question. Okay? Let's see what else. Ruben had 145.5 minutes of the 245.5 minutes that were downloaded by Tarek and him. So it looks like Ruben had 147.5 minutes, okay? And then it's talked about there being 245 minutes that were downloaded by Tarek and Ruben. So that sounds like a total. So what it looks like is that Ruben's number of minutes plus Tarek's number of minutes plus Ruben's number of minutes is equal to the total, which was the 245.5 minutes. Now notice when I write my equation, I do not use labels, okay? I don't use labels. So I know some of you are thinking, why can't I just subtract the two numbers and call it a day? Well, because we're trying to teach you how to write an equation where you have a variable, t, and math happening to it. I'm adding 147.5, because those two numbers together are the 245.5. Got it? Okay. I might have said that number twice. I'm sorry. So let's go ahead and solve this. How do we do that? We do inverse operations. So the inverse of adding is subtracting. So I'm going to subtract 147 and 5/10 from both sides. So I line everything up nice and neat. And remember from the notes from yesterday, when I add opposites, I get 0. So I get t equals, and then over to this side, I'm going to be doing my math. So I have 5 take away 5 is 0. I'm going to have to rename. And I get 15 take away 7 is 8. And I'm going to need to rename. And 13 take away 4 is 9. So I'm going to take that answer, and I'm going to say Tarek downloaded 98, and I could say 98.0, or since it is 0.0, I'm just going to say 98 minutes. And that's my answer. Okay, I'm going to go to the next page, and I'm going to add, this is now official next page, so I'll put the title back on. Oh, I did this yesterday, I don't know what my problem was. So we've got lesson 7-2 and lesson 7-3, writing equations. Using addition or subtraction. So I'm just going to do it this way. And we're still at 225, 2020. Okay, so example coming along. So this one says it takes 43 facial muscles to frown. This is 26 more muscles than it takes to smile. How many muscles does it take to smile? So I'm going to go ahead and take the question and write it as a statement. So I'm going to say M is equal to the number of muscles it takes to smile. Okay, and then I'm going to look for some numbers. I'm going to look for words that tell me equals. Let's see, what do I got here? I see 43 facial muscles. This is to frown, so that's not the answer to this question. And it says this. Yeah. Anytime you have a sentence that starts with this or that, it's referring to something that was already mentioned. So this is going to be the 43. Oh, ladies and gentlemen, looky what we have here. That means equals. Okay? I see another number. I see a 26. And then it says, ooh, look at that. It says more. Oh, I don't like that color. Sorry. Let's try another color. Let's try this one. More muscles than it takes to smile. Oh my goodness. Wait a second. Smile. That's what we don't know. Okay, so remember how this works. We've got an equals. More than is a switcher phrase. So 26 is going to come after the plus, and how much it takes to smile is going to switch around. So this is our switching, okay? So let's see if we can write this equation. Let's see. This, we're going to start with the 43. That's our equals. Let's see, 26 more muscles than, so we're going to change it. Adding, and the 26 is going to come at the back end. And then it takes to smile, and that's what I don't know, so that's my M. Ooh, they say. Okay, now I explained this in the video from yesterday. What we're trying to solve for is the variable, the unknown. So since that's what we're solving for, it should be the first thing I see in your answer. So what we're going to do is, I don't like it when it's written this way, so I'm going to pick up the right side, put it on the left, pick up the left side, and put it on the right. That's called the symmetric property of equality, and we have permission to do that. So let's see. We need to undo this math problem. So we've got adding 26. If I undo that, that'll get the M alone. So I'm going to subtract 26 from both sides. So remember, opposites give me 0. And we have that identity property of addition. Anything plus 0 is that thing. So I get M equals, and then I'm going to rename, and I get a 7, and I get a 1. So I get 17. Now I have to write this in a sentence. Number of muscles it takes to smile. It takes 17 muscles to smile. Oops, perhaps if I spelled it correctly. And there we go. All right, and I wrote so big that I ran myself out of room on the screen. So I'm going to go to one more screen, but it's still on the second page. And we've got one more problem to put in. So Georgia's height is 4 inches less than Sienna's height. Georgia is 58 inches tall. How tall is Sienna's height? So again, I like to start with the unknown. How tall is Sienna's height? So I'm going to say, I got to be honest with you. Be careful when you use a variable s, because it could look like a number 5. So I would say Sienna's height. Saying how tall is Sienna's height, that's really weird. How tall is Sienna? What is Sienna's height? Whatever. There we go. All right, let's start exploring back there. Georgia's height is, I just heard is. There's my equals. 4 inches less than, spaghetti-o. That says we're going to subtract, but it also says we're going to switch order. Okay, well, I do know one thing for sure. 4 is 4. So, Georgia's height is our, let's give it a nice good color. Do this color. Georgia's height is 48 inches less than Sienna's height. And then it says in the next sentence, Georgia is 58 inches tall. Okay? Sienna's height is our unknown, right? Okay. And we got a switcher. So here we go. Let's try it. So Georgia's height, which we just found out was 58, is, so that's our equals, 4 inches less than, so we have a subtraction problem, and we're going to switch the order so that the 4 comes after the subtraction. And then Sienna's height is the variable. Okay, but again, I don't like the way that it's written, so I'm going to pick up the right side, put it on the left, so my variable's on the left, and then equals, and then we have a constant, and he should be on the right, because that's where I want all my answers to end up. Constants on the right, variables on the left. Ooh, looky what we've got here. It says S take away 4 is equal to 50. 8. So the inverse of takeaway is adding. So I'm going to add 4 to both sides. I'm always trying to get the variable alone. To do that, I need to create opposites. So I get S is equal to 62. So we would say Sienna's height is 62, and the label was inches. Or you could say Sienna is 62 inches tall. That'll work too. All right, that's it for tonight, guys. We'll see you tomorrow. Bye.